Okay guys, welcome to Engineers Academy. Now we are going to solve this problem 951, and it says that the truss is made from 5 members, each having a length of 4 meter and a mass of 7 kg per meter. With the mass of the gusset plates at the joints and the thickness of the members can be calculated, determine the distance d. So we are required to find this distance d to where the hoisting cable must be attached so that the truss does not tip or rotate when it is lifted. So since this is the an assembly of 5 members, it's a truss, and we are required to find this d. So this d need to pass through the center of mass of this 5-member truss, or we can say that it should pass through this cable should pass through the centroid of this truss, so it will remain in equilibrium and it will not rotate. So we have to find this d. So in other words, we can say that if the centroid of this 5-member truss is located somewhere here, then this distance, let's say that this point is the centroid. So the distance of the centroid from the y-axis is always x bar. So from this we can conclude that this d will be equal to the x bar of the centroid. So we have to find the x bar. Now since we have 5 members, so we have to construct a table. So we have to write segments. So we have 5 segments: 1, 2, 3, 4 and 5, and then we have to find the mass of each segment. So we are given that the length of each segment is 4 meters and the mass per meter is given, right? So the mass per meter is 7 kg per meter. So the mass of each member will be let me write the total mass in kgs. That m will be equal to, let's say this is small mass, right? So small m into length of each member, so that is 7 kg per meter multiplied by 4 meters. So meter will cancel out, and that is 7 into 4 is 28. So each member has a mass of 28 kg. So let me write that this is 28, this is 28. So all members have a mass of 28 kgs. Then we have to find the centroid location of each member from the origin. So this is our origin, and we have to locate the centroid of each member. So that, and we have to find, since we want to find the x bar, so we have to find the x tilde, the location of the centroid of each and every member from the y-axis. So that is represented by x tilde. So as we know that this member is a rectangular member and its centroid will be somewhere here at its mid length. So from here to here, this distance will be 2 meters. Since the length of the member is 4 meters, so this distance needs to be 2 meters. And similarly, the centroid of this member will be at its mid length. So from here, that should be 2 meters. And for this member, the centroid need to be somewhere here. And for this member, since it's a horizontal, so its centroid need to be somewhere here. And this is an equilateral triangle. And this is a 4 meter, this is 4 meter, and this is 4 meter. So both of these triangles are equilateral triangles. And the centroid of this member will be at its mid length. So that will be somewhere here. So let's say that this member is, let's say, segment 1 or member 1. Let me write 1 here. This is segment 1. This is, let's say, segment 1. This is 2. This is 3. And this one is 4, let's say, and this is 5. So we have to find this distance of the centroid of segment 1 from the y-axis. So let's say if this is the centroid of member 1, let's say this is C1, let's say this is C2, let's say this is C3, this is C4, and this is C5. So the distance of C1 from the y-axis is x tilde 1. So we have to find this x tilde 1. and we are given that all these angles are 60 degrees. This is an equilateral triangle. So if this angle is 60, then we can make a triangle here. Let's say if I make a triangle like this, if we have a triangle like this, and this length is 2 meters, and if this angle is 60 degrees, so then this length, the horizontal distance of the centroid from the y-axis is, so that is 2 cos of 60 degrees. So this means that this x tilde 1 is 2 cos of 60 degrees and 2 cos of 60 is 1 meters. So we can write that x tilde 1 is 1 meters. So this is 1 meters. So I can write that x tilde 1 of the location of the centroid of the member 1 from the y-axis is 1 meter. So I will write 1. And then we have to multiply this x bar with this mass. So this is x tilde with that respective mass, right? So this will be 28 into 1. Since we know that the x bar, which is equal to d, will be equal to the summation of x tilde times mass divided by the summation of the mass, or we can say that the total mass, right? So this is the equation. So we need to find the summation of x tilde time mass. So we have to develop a table, and then we have to add up, and then we have to divide it by total mass. So now we have to locate the centroid of this segment 2. This is at C2. So its centroid will be at a distance of 2 meters. Since it is at the mid length of this segment 2, this is 2 meters. So we will write that this is 2, and then this is 28 multiplied by 2. Now this segment 3. So again, if I draw again a triangle here, if we have a triangle like this, so this length from here to here, this length is 2 meters. And again, this is 60 degrees. This is an equilateral triangle, so all these angles are 60 degrees. So if this is 60, then this length is 2 cos of 60, and this is 1 meters as well. So this is 1 meters, and this from A to D, the length is 4 meters. So the C3 is at a distance of 3 meters. From here to here, this distance will be 4 minus 1. So this is 3 meters. So from this we can say that the centroid of member 3 is located at a distance of 3 meters from the y-axis. So x tilde 3 is 3 meters. So we will write that this is 3. And now this is 28 multiplied by 3. And similarly, the centroid of this segment 4 or member 4 is at a distance of, this is the distance, this is x tilde 4. Let me write it, this is x tilde 4. And this will be from here to here, this length is 2 meters since it's an equilateral triangle. So if this is an equilateral triangle like this, and if this is 4 meters, this is 4 meters, and this is 4 meters, and if this angle is 60 degrees, so if I drop perpendicular from here, so this length is 2 meters, right? So it will intersect this this member. So the whole length is 4 meters, then this distance is 2 meters. And if I draw a triangle like this, so this is 2 meters as well. So from this we can say that from here to here, this distance is 2 meters. And then this is at the C4 is at its mid length of this member. So from here to here, this is also 2 meters. So from this we can say that the centroid of this member from the y-axis is at a distance of 2 plus 2 meters. So that is at a distance of 4 meters. So I will write that this is 4. So this is 28 into 4. And similarly, again, we can say if I draw a triangle here, so again this distance, since this is 2 and this angle is 60, so this is 2 cos of 60 and this is 1 meter. So the distance of the centroid of this fifth member from the y-axis will be this 4 meters plus this 1 meter. So that is at a distance of 5 meters. So I will write 5. So this is 28 multiplied by 5. So now if we add up all of these, so 28 is common. So we can, this will be the summation of x tilde times n, and this is equal to 28 into 1 plus 2 plus 3 plus 4 plus 5. and the total mass will be, since this is all the masses are equal, so this will be 5 multiplied by 28. So this is the summation of mass, or we can say that this is the total mass of the truss. So we can say that x bar, which is equal to that d, will be equal to this, which is 28 into 1 plus 2 plus 3 plus 4 plus 5, and divided by 5 times 28. So that is 5 times 28. So 28 will cancel out and we will be left with this. So the x bar, or the distance d from the y-axis, is 1 plus 2 plus 3 plus 4 plus 5 divided by 5, and this gives us 3. So from this we can write that that distance d is 3 meters. So the centroid of this whole truss is at a distance of 3 meters from the y-axis. So this distance d, which is equal to x bar, is equal to 3 meters. So this is that distance d where we need to hoist the cable so that the truss does not slip. So this is the solution of this particular problem. I hope this will help you in your learning. Do let me know in the comments if it helps in your learning. Also subscribe my channel if you are here for the first time.